Alright. In this tutorial, I'm going to talk about linear first-order equations and then substitution and exact equation. I thought you guys did the second part, substitution and exact equations, yesterday. That's why I'm doing it, but based on the feedback from my last tutorial, you guys did not do it yesterday. So I suppose this is gonna be new for you. I can't change my tutorial material now, so I'll still do it. And hopefully I don't lost all of you. Based on my last two tutorials, they were not lost, so hopefully I don't lost you guys either. I'll try to explain everything clearly so that, well, because I'm really ahead of your lecture. And well, but in that case, I hope my tutorials can help you understand your lecture then. Anyway, let's start. We have linear first-order equation. So first-order linear equations looks like this. This is the form of first-order linear differential equation. Basically, you have a function of x times the first derivative of y plus another function of x times y itself equals to g of x. That's the form of first-order linear equation. Now, if your g of x equals to 0, this is called homogeneous. If your g of x is not 0, then this is called inhomogeneous. All right. Now we want you to have a standard form, which looks like this. The standard form is basically you divide every single term by a1 of x. So divided a1 of x. So if you divide every single term by a1 of x, that's going to give you the standard form, which is this. So here your py is going to be a0 over a1, a0x over a1x, because they are functions. And your q of x is going to be g of x over a1 of x. The reason we want it to be standard form is because later when you find the integrating factor of this, it's going to be easier for you, okay? So make sure you know standard form. Basically, you want your y prime or dy over dx, the coefficient to be 1. Anyway, let's look at an example. So this is a first-order differential equation. As you can see, this part, this is your a1 of x. This whole thing, this whole thing is going to be your a0 of x. And this whole thing is your g of x. So my question is this ODE homogeneous or not? No, okay, this is not homogeneous. Now, can you write it in a standard form? So we want standard form, so let's write it down. That's going to be dy over dx minus 2 cosine of x over 13x squared. Y equals to e to the x plus x over 13x squared. Okay, so this is your standard form. Anyway, let's look at integrating factor. So for any linear differential equation, remember this is your standard form, okay? Really important. We define the integrating factor Ix to be e to the power of integral of p of x dx. So you take the integral of this, e to the power of integral of this. Now, let's look at this example. What is the integrating factor of this differential equations? I'll give you 1 minute to think about it. Remember, you need to use this equation, okay? What is the integrating factor of this? E to the x cube, e to the 6x. Yes, e to the x cube, okay? So your I of x is gonna be e to the integral of 3x squared dx. That's gonna give you e to the x cube, okay? Seems like this is clear for you guys, so let's move on. Now I will talk about how do we solve first order linear differential equations. So first of all, you write it in standard form, and this is a standard form. After you write it in standard form, you find the integrating factor. So this is e to the power of integral of px dx. After you find your integrating factor, you multiply both sides of the differential equation by this. So you multiply everything by this. So you put here, here, and here. And then you recollapse it as a product rule. You might not understand it now, but when we see the example, you understand it later. And then you integrate both sides of the result, isolate for y, and use additional information. Additional information usually is like initial value to find your constant. Again, this might not be clear now, but we'll use an example to clear it up, okay? So let's write it down. So this is my ODE. This ODE, you've seen it before. In your last example, I asked you to find the integrating factor. So as you can see, this ODE is already in standard form, so we don't have step 1. Step 2, calculate the integrating factor, which we did already. That's going to be e to the x cube. You guys did it already. So this is from 1a. The third step is you want to multiply both sides of the differential equation by the integrating factor. So let's do that. That's going to give you e to the x cube y prime plus e to the x cube 3x squared y equals to e to the x cube e to the negative x cube. Okay, so that's our third step. I multiplied everything. I multiplied everything by this integrating factor. Now, number 4, you want to recollapse the left-hand side as a product rule. How do I do that? You can see this is a product rule of something. And after write it down, it should be clear, okay? So this is going to be d over dx of e to the x cube y. So if you take the derivative of this, you see that you'll get e to the x cubed y prime plus e to the x cubed 3x squared y. So this, if you take the product rule, you get this. So you reclass it back in this. That's gonna give you, the right hand side is gonna give you 1. Is anyone able to access? You are not able to download it? You're not able to download it? Okay. I thought you are, okay. Let me check. Let me check. It should be here. Try again. It should be here. Okay, let's go back. So we finished step 4. Now let's just integrate both sides of the result. Can you guys hear me? Okay, cool. So let's continue. Now we just need to integrate both sides of the result. So that's going to give you e to the x cubed y. Integrate 1, that's going to give you x plus a constant. Okay, so that's your step 5. Step 6, you isolate for y, so you divide each your term by x, e to the x cubed. That's going to give you y equals to x times e to the negative x cubed plus c times e to the negative x cubed. All right, and that's your final solution because we don't have initial value. So this is your final solution. All right, any question? Anyone has any question? Is this clear? How do we get e to the x? E to the x, you mean here? Yes, it is. It's not product rule backwards. Oh, it kinda, yeah, kind of like that, yeah. Yeah, so here, basically you just make an observation. This is a product rule. So this is a derivative of this. Basically you make an observation. But most likely, I'll give you a trick. So if you can't see, most likely this is gonna be, okay, most likely when you recollapse it, this is gonna be d over dx, your integrating factor, all right, your integrating factor times y. Okay, you'll see that in the next example as well. It's basically this. It's basically this. Anyway, can we move on to the next example? Okay. Example 2, I want you to find the solution of the following problem. For this question, I want you to try it yourself. So I'll give you, let's say, 5 to 8 minutes to work on this and we'll take it up, okay? When calculating the intervening factor, should we add a plus c constant? You don't need to. You don't need to because that constants can be observed by the later constant you add. So for example, the reason that let me write it here. The reason that we don't add a constant here, is because later, even if you add a constant there, okay, let's say, so plus c, that's gonna give you e to the x cubed, e to the c. So this is a constant, right? This constant later can be observed by this constant. So eventually you only have one constant. So you don't need to, because that's gonna make your expression really complicated, which is unnecessary. Okay, do you guys need more time? Are you good? Okay, no one said anything. I suppose you guys all finished it. Even if you are not done yet, just don't look at the screen yet. Keep writing, and I'm not gonna talk. I'm just gonna write down my solution, and after I wrote it down, I will start to explain. And then I suppose at that moment you should be able to finish it already. Anyway. Okay. All right. So that is it. Now I just need to plug it back in, and I'll get my final solution. Plus 26 over 25 e to the negative 4x. Okay, so this is a final thing. Alright, so let me just go over what I did, which is basically the same thing as the last example. First of all, this is a standard form already, so you don't need to rearrange it. So your integrating factor is e to the integral of 4 here, dx, which will give you e to the 4x. Then you multiply both sides of the equation by your integrating factor. That's going to give you this. And you can reclapse this by writing it to be e to the 4xy prime. I skipped a step because I'm a lazy person. Anyway, and then then you take integral on both sides. That's gonna give you the step, and then you use integration by parts. You can find this. Okay, and then you isolate your y, so you divide both sides by e to the 4x. That's gonna give you this. Then, since you have an initial value, so you plug it back in that y equals to 1, x equal to 0, and you can calculate your c and plug back in your c to this equation, and that's going to give you this. Any question? Question? No one has question? Is this clear? Is it all clear? Clear. Cool. Next. Okay, here's a fun part where you guys didn't learn in lecture. I don't know why, but whatever. We can use substitution when we try to solve differential equations. So we have a homogeneous differential equation, look like this. If we make the substitution that v equals to y over x, then y equals to ux and dy over dx equals to v plus x times dv over dx, then this whole equation can be transformed into a separable equation, which looks like this. And then you can just integrate both sides, dx dv. Okay, so you integrate both sides and you can solve this equation. That's the concept. That's might not be clear, but after we did this example, it should be really clear, crystal clear. Okay, so here we have an ODE. It's really hard to solve it, but if we use substitution, it's gonna be easy. So let me show you. What I'm gonna do is I'm gonna try to convert this as a function of y over x. So how can I do that? I can divide the numerator and denominator by x. So that's gonna give you y over x minus 4 1 over 1 minus y over x. Now you can see this is a function of y over x. So we can make the substitution. So let u be y over x. Oh, my y looks like a v. Y over x. Then my y equals to ux. Now our dy over dx is gonna be d of ux over dx, which is du over dx times x plus u. And now you can substitute your u back in there. That's gonna give you u minus 4 over 1 minus u. Okay, here you have a separable ODE. You move your u to the other side of the equation. Okay, let's do that. Du over dx times x is gonna give you u minus 4 over 1 minus u minus u, and you can common denominator. It's gonna get u squared minus 4 over 1 minus u. And this is a separable ODE, so we can just take the integral on both sides. What I'm gonna do right now is I'm gonna flip it so that it's easier for me to integrate it. Why is that? Because this is really hard to integrate. But if you flip it, and that's gonna be easier. Well, that's dux over dx is gonna be d. So you take the derivative of u first. So that's gonna be du dx. Oops. You take the derivative of u first, leave x alone. So that's gonna be x times du dx. And then you take then you leave u alone and take the derivative of x. That's gonna give you 1, so that's gonna be u. Does that make sense? So basically it's like ux prime. So that's gonna be ux times u prime plus u times x prime, which is 1. It's the same thing, okay? All right, anyway, continue. Take the integral on both sides. I flip this so it's 1 over x dx equals to 1 minus u over x squared minus 4 du. Wait, where did I get x? This should be u, sorry. u squared minus 4. Alright, now this part should be simple to take integral, so that's gonna be ln x equals 2. This is a huge monster. Anyone remember how do we do it? Think back in 135, think back in 135. How do we integrate this? Anyone know? Trig sub? No. No, we don't need trig sub. We need partial fraction, okay? Partial fraction is what we need. Okay, let me use another color here and write it on this side. So we have 1 minus u over u squared minus 4 equals to, let me write u squared minus 4 as u minus 2 times u plus 2. So let's let this equals to a over u minus 2 plus b over u plus 2. Okay, and let's add them together. That's gonna be a times u plus 2 plus b times u minus 2 over u minus 2 times u plus 2. And that's gonna give you au plus bu, so a plus b u 2a plus 2a minus 2b, so that's gonna be minus 2. Wait, yeah, actually, plus 2a minus 2b over u minus 2 times u plus 2, and that's gonna give you two different equations. First of all, we know this equals to this, so u times a constant, which is a plus b. That's going to give you negative u, so a plus b is going to give you negative 1. Next, 2a minus 2b is going to give you 1. So you need to solve those two equations. Minus 2b equals to 1. So let's solve this. A plus b equals to negative 1 times 2. That's 2a plus 2b equals to negative 2. Add them together. So that's 4a equals to, oh, I made a mistake. Oh no, never mind. Yeah, it's right. So that's gonna give you a equals to negative 1 over 4. B, negative 1 over 4 plus b equals to negative 1. So b is negative 3 over 4. Okay? Now you can put it back. Put it back. This will give you the integral of negative 1 over 4 times 1 over u minus 2 minus 3 over 4 times 1 over u plus 2 du. Okay? This whole thing du. And anyone know what's this? The integral of this? Well, this is just ln of that. Negative 1 over 4 ln of u minus 2 minus 3 over 4 ln u plus 2. Now you just need to sub it back in. We know u equals to y over x. Oops. U equals to y over x, so you plug it back in. That's going to give you now x equals to -1/4. Now y over x minus 2 minus 3/4 ln y over x plus 2. Okay, so that's your final solution. The only hard part is a partial fraction, I hope. So based on this, you guys should see that this course is computation heavy, really heavy. So if you forgot about your 135 and 232 materials, please review. Make sure you know how to take integration and derivative. Really important. Make sure you know all the techniques, integration by parts, trig, substitution, partial fraction. Review all those, okay? Otherwise, I'm gonna. You don't need to. You can leave it like this. You can leave it like this. You don't have to write it as a explicit equation, because right now it's a function of y. No, I mean now right now you only have y. Okay. Anyway, I wanna give you a question to do. So let's try this question. I'll give you 5 minutes. Let me think. This question, yeah, I don't think it has anything complicated, so it should be fast. Guys, let's try this question. Try it yourself, okay? Did I lost you guys? Is it clear? I hope I didn't lose anyone. I hope this is clear, because I know you guys didn't do it in lecture. I didn't know that. Honestly, I didn't know that. Because his plan was to cover this. Yeah, I think he'll do it in next lecture. Yeah. So it turned out my tutorial to be ahead of lecture, which I did not expect this. Because he was gonna cover this yesterday, and apparently because people didn't understand integrating factor and variation of constant, so he reviewed for that part. That's why he didn't cover it. But he will teach you guys this next lecture, I suppose. But I hope this makes sense to you. Okay? It's mainly just computation, honestly. Yeah, I don't like computation. I am not a big fan of computation. The reason I don't like computation is I think for computation, the computer can do it much faster than human. Then why are we even doing it ourselves? That's my point. But for proof, you have to do it, like you have to use your brain to do your proof. But for computation, you can just like plug everything in the computer and let it do it yourself. So I don't understand why we're doing computation, honestly.
And it's like you plug things in and you do it without your brain. I mean, you still need your brain to do it, but I'm just saying you don't need to think much. And that takes away the fun of math. Anyway, I don't want to say too much bad things about this course. Although I feel like I told you guys, not you guys, because last week I canceled my tutorial, but I told my other students that I don't like this course, and the only reason that I accept the offer of this course is because Tyler told me if I accept 244, he's gonna give you 2 more sections of 102. That's the only reason I accept the offer. But as a student, when I took the course, I absolutely hate it. Yeah, 102 TA is much more fun. uh, Most of the TAs we don't like this course because we don't like computation. I mean, most of the math TAs don't like computation, so we don't want to TA such courses. Like 232, 244. I don't know. The offer will be sent out at the end of December. I might not even get hired because I'm in Unit 3. Because they hire Unit 1 and grad student first. They don't like Unit 3. Because I graduated, I'm not a student anymore. So I might not even get hired, but we'll see. 102, teach 102 is so much more fun. Except I TA'd that course so many times, I know every single question already. I know the course inside out. And at this moment, I don't know what's easy and hard for that course anymore. Because, like, every single question, I see them, and within 30 seconds, I know exactly how to do it already. So I don't, because I TA'd the course so many times. So it's getting boring for me as well. So I'm thinking that I might apply another proof course, but we'll see because they might not even want me anymore. So we'll see. Anyway, enough of chit chatting. Are we guys? Are you guys done with this question? Can I take it up? Because we still have exact differential equations to cover. Come on, guys, down. Let me just write down the solution, and by the time I finish writing, you guys should be able to finish. So oops. Alright, I'm done writing. Hopefully you guys are done as well. Basically, what I'm doing is I divided my denominator and numerator both by x squared to get a function of y over x. So that's my first step. And then I use substitution, let u be y over x and y equals to ux. And then you do the same thing over here. Basically the same thing as last question. And you sub your u back into this equation. That's going to give you 1 plus, this one. That's going to be 1 plus 3u squared over 2u. And then you move your u to the other side. That's going to give you this, which is a separable differential equation. So we take the integral on both sides. Again, I flipped it because this is really hard to integrate. And then you get this. As you can see, this will give you ln of 1 plus u squared. This is ln of x. So you plug your u equals to y over x squared back in, and you can get this. And that's your final solution. Okay, I think this is clear, so let's move on, because we don't have enough time. Exact differential equations looks like this. Okay, this is a standard form of exact differential equations. It looks like this. And if we have a function psi such that if you take the partial derivative of psi with respect to x, you can get m. And if you take the partial derivative of psi with respect to y, you can get n. Then this differential equation is exact differential equations. Okay, this might not make sense to you so far, but later when we do an example, it should make sense, but it's 1 o'clock already. This is awkward. It's 1 o'clock already. Let's say this. I'm gonna stay here, continue, finish the last example. If you wanna leave, you can leave now, since the recording will be uploaded, but I wanna stay and finish the last example. Okay, I mean second last example, actually. Separate recording? Oh, I just wanna finish this example, it should be fast. Right now it's my office hours, so let's just continue, because I finished this example for my other two tutorials as well. Okay, let me just continue. So far you don't even know what your psi is. You don't even know what this is, so it's really hard to check if it's exact or not. So to check if a function is exact, not function, if an equation, if an ODE is an exact ODE, you need to check if n of y equals to n of x. So if this is true, then it's exact. So that's your first step. Your first step is to check if this is true. Let me just go straight to the example. So we have an ODE that looks like this. As you can see, this looks exactly like this, which means this is our m. Oh, no. Okay, which means this is our m and this is our n. Okay, so your first step is to check if it's exact. So to check if it's exact, you take m with respect to y, that's gonna give you 4xy plus 2. And you take partial derivative of n with respect to x, that's gonna give you 4xy plus 2 as well. So they're equal. Since they're equal, that means it's exact. Since it's exact, that means we have a function psi such that those two are true. Okay, so we can use it to find our function psi. So this means there exists a function psi such that your psi of psi of x equals to m and psi of y equals to n. Now we can solve for psi because we know those two are true. So if you take integral on both sides, you can find your psi. Okay, so your psi equals to integrate of m dx. That's gonna give you psi of 2xy squared plus 2y, the whole thing dx. And that's gonna give you y squared x squared plus 2xy plus a constant. Okay, so now you need to add a constant, but notice that our psi is a function of x and y. Here, when you take the integral, you only care about x, which means your constant is going to be a function of y. Let's call it h of y. Okay, so this is your constant, which is a function of y. Now our problem is, we know this is our psi, but we don't know what h of y is. So we need to find this out. Okay, after we find it out, we're done. Now, this condition here, we never used this, so we can use this. We know that if we take the partial derivative of psi with respect to y, you can get back to your n. So this is your psi, take the partial derivative with respect to y, will give you back this. So if you let them equal, you can find your h of y. So let's do that. Phi of y is gonna equal to 2x squared y plus 2x plus h prime of y. We know this is gonna equal to n, which is 2x squared y plus 2x. We know they're gonna be equal, so cross them out. That's gonna tell you that our h prime of y equals to 0. Since h prime of y equals to 0, we can take integral on both sides to find our h of y, which has to be a constant. Okay, so our h of y is a constant. So since we know h of y is a constant, you plug it back in here. That's gonna give you our psi y squared x squared plus 2xy plus c. And if you let it equal to 0, this whole thing is gonna be your final solution. Okay, this is your final solution. So x squared y squared plus 2xy plus c equals to 0. This is your final solution. Again, I'll go over what I did here. Okay, first of all, your first step is you want to check if the ODE is exact by taking the partial derivative of m with respect to y and take the partial derivative of n with respect to x. If they are equal, then it's exact. If it's exact, we know there exists such psi function. Psi is a function of x and y such that psi of x equals to m and psi of y equals to n. Since we know those two conditions, we can take the integral of either of them to calculate our psi. So I took this one and take the integral on n with respect to x. That's gonna give you this. And remember, psi is a function of x and y. Here you only care about x, so your constant has to be a function of y. Okay, so you have this. That's your psi. We don't know what's the function of y, so we need to calculate it by using the condition left. So let's take the partial derivative of psi with respect to y. That's going to give you this. We know it equals to n, So you let it equals to n, and you can find your h prime of y. After you know your h prime of y, you can take the integral to get your h of y. And you plug it back in, whatever sign you get is gonna be your final solution. Okay, any question? Question? Alright, seems like no one has any question. I hope this is clear. If not, I guess I'll find more examples of this next week. So we'll continue talk about this, and we'll continue talk about when you have a differential equation, but it's not exact. How can we make it an exact equation and still you can still solve it? So that's my next goal. That's here. So we'll do it next week. Since I'm ahead of your lecture already, we can do everything again next week. So I'll find more examples. We'll do more examples next week. We'll talk about what happens if it's not exact. How do we solve it? If no question, you guys can leave, and I'll move to my office hours if you have any question. Okay. Alright, that's the end of the tutorial. You guys can leave, and I'll stop recording. Bye. Have a good weekend.